How about now? Yay! we have sound. Thank you so much. Yeah. So for some reason, my mic was turned down. I totally forgot to turn it on. So thank you, Peter, for that. Okay. So let me let me go back and explain what I was just saying. Um, so um, Basically, what I was saying is that I had a question about the cubic formula. So for many of you, maybe you've heard about the quadratic formula, and I'll put it up here real quick so you can see that. Let's see here. Here we go. There we go. Let me post the quadratic formula real quick here. So for many of you, maybe you've heard about the quadratic formula, and I'll put it up here real quick. Okay, so if I have something like 2x squared plus 3x plus 4 equals 0. This actually has a solution maybe. It might be two real solutions. It might be two complex solutions, but there are solutions to this. And there could be real solutions. And the formula for the quadratic formula is x equals negative b over 2a plus or minus square root of b squared minus 4ac. That is a really bad C, so let me try that one more time. All over 2a. Now, for a lot of you guys might be looking at this and you're like, why did you have over 2a twice? Why did you split that up into two fractions? Why didn't you keep it as one fraction? The main reason is because, I don't know if you guys know this, but this is the x value for the vertex of a parabola. And what I like to think about a parabola, if you draw a parabola real quick, let me clear this page. So if you have a parabola, that is a really bad parabola. Let me try one more time. Okay, so here's a parabola, and here's the x-axis. So here we have our two zeros, our two x-intercepts, but right here in the middle is the x value of our vertex. So that is our vertex right there of the parabola. And this right here, this x value is x equals negative b over 2a. And for those of you who have taken pre-calculus, hopefully you should know that. Now, to get the quadratic formula is negative b over 2a plus or minus, that's this direction right here, the square root of b squared minus 4ac all over 2a. So that is what's called, well, this is the distance from the x value of the vertex to the zeros. But that's beside the point. The question that I got, real quick, let me change views. The question that I got was, what, let me make sure my audio is working right.
There we go. Let me use this audio. This audio is a lot better. So I'm using this microphone right here. Yeah. So I got a question from Be Smart. I never heard of Vertex Parabola till now. I'll go into more detail about that. But let me address this question that I got about the cubic formula. So if I have a cubic polynomial, meaning like x cubed plus 2x squared plus 3x plus 4. What's the formula for finding the zeros? There's this quadratic formula, but is there a cubic formula? And the answer is yes, which is really weird. When I brought up this book, I was mentioning how this book actually has this formula, and it proves the formula too. If you don't have this book, it's called Abstract Algebra, and it's by Dummett and Foote, right over here. For all of my viewers who are graduate students in mathematics, getting their PhD in math, you've probably read this entire book front to back and probably solved every single problem This book is absolutely insane, and it talks about the cubic formula. But I do want to warn you. By the way, I hope my microphone is working. Not sure if my microphone is working. Can you guys hear me? Anyone? I think you guys can hear me. Okay. So yeah, buy this book. It has the solution to finding the cubic formula, which is pretty awesome. But it's really, really long, and I actually don't know it. And okay, perfect. Thank you, Be Smart. I appreciate it. It's really long. I don't know it, and I don't want to go over it because it's just absolutely insane. But I did have a request for talking about polynomials or parabolas. So let me go into some parabola math. Thank you, Peter. All right, so let me pull up real quick my other screen. And let's turn this into a pen. Here we go. I like this screen better. Let's do this. Yay, very good. It's a very nice drawing. Okay, so let's suppose I have something like 2x squared plus 3x minus 10 equals 0. So the question is, how do I find the solution to this? And if you've taken some sort of algebra class, you might be tempted to try to get x on one side. And that's actually not a bad idea, but there's a clever trick that you'll need to pull if you want to try this attempt. So let me explain what I mean. If you try to do something like add 10 on both sides, you get 2x squared plus 3x equals 10. And then the question is, how do you solve for x? Well, maybe you can factor out an x, but there's going to be no way of you fixing this problem because you have two terms that both have an x, and there's no way to consolidate those two things together because x squared and x are genuinely two different things, So this is not a way of solving this problem, which is why we have the quadratic formula. Now, I am going to show you a clever trick to do from here, but let me start with a different problem to make it a little bit easier to deal with. Let's say I had 2x squared plus 4x minus 10. Now, the reason I changed it to 4 is because this problem is a lot easier if I use 4. So the first step you always want to do if you want to solve a quadratic polynomial and find the roots to this is to actually get rid of this number right here. So this 2 right here, I'm going to get rid of it. And the way I do that is I divide everything by that number. And that's regardless of what that number actually is. So I'm going to divide everything by 2. And here I have x squared plus 2x minus 5 equals 0. You notice how the numbers got divided by 2. So 2 divided by 2 is 1, but we don't really put a 1 in front of x squared. 4 divided by 2 is 2. Negative 10 divided by 2 is negative 5. 0 divided by 2 is 0. And so now I'm solving this problem right here. Now, to solve this problem, I'm going to add 5 to both sides. And many of you might know what, or might anticipate what I'm going to do here. But I'm going to do what's called completing the square. I'm going to add a term here. I'm going to put a number right here. But in order for me, so that everything works out pretty nicely. But in order for me to do that, I can't just stick a number there. That's not how equations work. If I do one thing on one side, I need to do something to the other side to keep the equation balanced so I don't change any information. Real quick though, I have x squared plus 2x equals 5, and so I'm going to write that here. X squared plus 2x equals 5. Now I'm going to add a number to this left-hand side, and this number is a very clever trick. I'm going to take this number right here, this 2, and I'm going to divide it by 2. And then I'm going to square it. That's right, yes. So I divide it by 2. 2 divided by 2 is 1. And then I'm going to square that number, 1, which is 1. So I'm going to add 1 to both sides. Keep in mind, I can't just throw a 1 there. I have to throw it on both sides of this equation symbol. So Now that I've done that, 5 plus 1, by the way, is 6, but we'll worry about that later. Now I have what's called a perfect square. And you might know what a perfect square is. There's plenty of those, like 1, 4, 9, 16, 25. Those all numbers are perfect squares. This is actually a perfect square. It happens to be x plus 1 squared equals 6. Now the question is, what do you do next? Well, we have to take the square root of both sides, but it's important to understand that when we have a square here and we're square rooting a square, we actually get a plus or minus value at the end. So I'm going to square root both sides, and this is x plus 1 equals plus or minus the square root of 6, which is -1 plus or minus the square root of 6. So this is me solving a quadratic polynomial without actually using the quadratic formula, and it's using the method complete the square. But if you remember, those numbers happen to be pretty convenient. But I'm going to solve a quadratic polynomial and develop the quadratic formula for you guys. So if you've never seen the quadratic formula developed, I'm actually going to do that right now. Before I do that, though, I just want to double check to see if there's any comments or questions. So let's see here. I don't think I have any yet, but that's okay. I'm actually pulling up my YouTube channel right now and seeing if I have any. I got 4 more subscribers. Thank you guys. If you haven't subscribed yet, make sure you subscribe. And if you have any questions, make sure you, I think it's in this direction, over this random like video thing that's going on that's kind of crazy, make sure you post your questions in the live chat too. All right, so let's see here. I'm going to go to my channel, and I'm going to see if I have any comments. I don't believe I do. After this, we will definitely develop the quadratic formula together. Looks like we have no comments. Great. So let's get started. Yeah. So add the link to. I will add the link of the book in the description right now. Actually, let me pull that up real quick so I can get that to you. Dummett and Foot PDF. I totally did not just take this from the internet. I'm looking up the actual PDF itself. This is not it. I think this is it. Maybe we could try this. Okay, I want to say this is it, so let me add this to the link real quick, or the description. Let me get that link to you. This is actually a free PDF of this book. If you want, just search Abstract Algebra Dummett and Foot on Amazon. Use the free PDF, it's better, and it's free, and I think they even offer it for free. Let's see here. All right, so that was, I added that link to the description. There you go, be smart. Now let's go back to the quadratic formula. If any of you guys have any questions, again, feel free to add your questions to the live chat. This is a good conversation. All right, so let's talk about a general quadratic polynomial. So this would be something like ax squared plus bx plus c equals 0. So the question is, in general, what is the solution? So just like the last problem, the first step I'm going to do is I'm going to get rid of this a. So I'm going to divide every single thing by a. And I'm going to be left with x squared plus b over a x plus c over a equals 0. So now I want to get rid of this guy right here. I'm going to move him over there. So I'm going to subtract both sides by c over a. And this leaves me with x squared plus b over a x equals negative c divided by a. So the question is, now what do I do? Now the solution is you have to complete the square. So you have to take this value right here, divide by 2, and then square it. So I'm actually going to take both sides and I'm going to add b over a divided by 2 squared to both sides. And let me show you what that looks like. This is getting kind of messy, so let me erase everything here. And I'm going to bring this over. Alrighty, so I have x squared plus b over a x plus, and I'm going to simplify this guy in the parentheses. When you divide by an integer, it's just the same thing as multiplying by the reciprocal. So this is actually just b over 2a squared, which, by the way, that's where that b over 2a is coming from. You can recognize that. It's starting to come together a little bit. Equals minus c over 2a. Minus c over a. Messed that up. And then plus b over 2a squared. So that's me. I've added this term on both sides of the equation, but it's important that I did that because now I can actually factor this left side. This left side is, by design, a perfect square. And it's actually x plus b over 2a squared. Yep. So you can actually check this if you want. If you FOIL that out, you will get x squared plus b over a x plus b over 2a squared. But this is equal to negative c over a plus, I'm going to simplify this, I'm going to actually square this out, b squared over 4a squared. Oh, that's kind of weird. We'll fix this later. Over here, though, what we're going to do is we're actually going to take the square root of both sides. So x plus b over 2a equals plus or minus, don't forget that, plus or minus the square root of negative c over a plus b squared over 4a squared. Whew, this is kind of fancy. It's getting there. And then we can simplify this to x equals negative b over 2a plus or minus the square root of negative c over a plus b squared over 4a squared. Now let's talk about this. So it looks pretty good, but let's talk about this. This happens to be the thing that we add and subtract, but we need to simplify it a little bit. So let's simplify that over here. Everything's looking pretty good. No mistakes so far, which, knowing me, is pretty good. All right, so let's just talk about negative c over a plus b squared over 4a squared. Let's see, how would we add two fractions in general? Well, you can only add two fractions if they have the same denominator. So I'm going to change this first fraction to have the denominator 4a squared. So this is the same thing as negative c over a, but I'm going to multiply both the numerator and the denominator by 4a. And let me explain why I can do that. It's basically, if you've ever simplified a fraction, I'm just unsimplifying it. Instead of dividing both the numerator and the denominator by a number, I'm actually multiplying both the numerator and the denominator by a number. But 4a divided by 4a is just 1. A number divided by itself is just 1. And so I'm just multiplying by 1. And multiplying by 1 does not change the number. So this is negative 4ac. I'm rewriting this numerator a little bit. I'm putting the 4 first, I'm putting the a second, and the c next. All over 4a squared plus b squared over 4a squared. Now I'm going to keep this thing right here because this is my final answer, but I need to simplify that square root a little bit. So I'm going to erase all of this. Getting there. I need a bigger eraser. You know, with my in my classrooms at ACU, I have a smart board where I can just make a little circle and then it'll just erase everything. They need to do that. So I'm gonna now that these denominators are the same, I can just add them. But I'm gonna rewrite it as b squared minus 4ac all over 4a squared. And if you remember, there's a square root over this entire thing. So I'm going to put that square root there. Now, the square root can actually distribute to the numerator and the denominator. So this is the same thing as the square root of, let's undo that. The square root of b squared minus 4ac all over the square root of 4a squared, which, by the way, is the square root of b squared minus 4ac all over, square root of 4 is 2, square root of a squared is a. Technically, though, there is a mistake in this formula. There is one thing that I did wrong, and most math teachers, if any of you guys have seen this before, will actually make this mistake. The square root of a squared is actually the absolute value of a. So, but it turns out that it actually makes no difference because when I have this plus or minus, if a is negative, then it'll just flip the sign and it'll work anyways. But technically, if you want to keep your math consistent, that a should actually have an absolute value symbol around it. So let me show you what the formula should look like. It should be x equals negative b over 2a plus or minus, the square root of b squared minus 4ac all over 2 absolute value of a. That should be the formula, but unfortunately it's not. Now I want to explain why this is, why the square root of a squared is actually equal to the absolute value of a. This is a common mistake that a lot of people make, but I'm going to explain that if we have time. Let me see if we have any questions at all, though. Looks like we don't. Do we have any comments? I don't see any comments at this point. That's okay. There's no problem with that. If you guys have any comments, make sure you drop a comment for your math questions, or maybe you like this video and you want to say, hey, thanks for this video, whatever. Make sure you like the video. I do want to mention one quick thing before we move on to this explanation about the square root of the square. Make sure you subscribe and like these videos because you'll be able to get a reminder for whenever we do a YouTube live event. We do YouTube live, as it says, it's like scrolling down below here. It says that we do a YouTube live event every Thursday and Sunday at 9 p.m. Eastern time. And I know for many of you, you're going back to school. Maybe you're in middle school, high school. That will be starting up, I believe, next Monday for most schools in the U.S. public school system. And then for universities, most universities start somewhere in the middle of August. My school starts in about a little bit less than 2 weeks from now. And I'm actually going to be bringing a lot of my students into this. So make sure you utilize this resource when you're doing your classes. And keep in mind, I know we only have 3 viewers right now. That's perfectly okay. Keep in mind, this will blow up once I get 200 of my students to be up on here asking all of their questions, wondering how they do their math problems for their liberal arts math, calculus, whatever it might be. But for now, if you have any math questions, maybe you want to know what infinity is, maybe you want to know what 0 is, maybe you want to know what we can do with those numbers, whatever your math questions might be, make sure you comment in the live chat or comment below. I highly recommend doing both. I'm going to be looking at the live chat personally, but it's up to you guys if you want to do something like that. Also, if you notice right here, it says Amour Learning. Make sure you check out the Facebook page, the Twitter page. Well, Twitter is actually Cody Amour. That's okay, that's just my name. If you want to know how to spell that, it's actually in the live chat. I've done several posts there. And then we also have our free courses on amourlearning.org. Just provide some free courses. There will be a liberal arts math course coming up in the next 2 weeks. That's going to be our first free online math course. If you don't know what liberal arts mathematics is, you can just call it statistics. It's a statistics course and it is free and it makes sense, I hope. So anyways, let's go into some other explanations. Okay, so I saw a couple people wondering, like, if I have x equals the square root of 9, what's the solution to this? And it was a Facebook post in the mathematics Facebook page. If you haven't checked them out, make sure you follow them. It's pretty cool. Although you get some really, really strange math questions. I see, you have 2 options. Either it's 3 or it's plus or minus 3. And the question is, which one do we choose here? And the answer is actually complex, but the answer is this one right here, x equals 3. It's not plus or minus. And I'll explain why, but let me show you the problem where you actually do need to use a plus or minus. If it was, if you use x squared equals 9, this does have a solution of x equals plus or minus 3. But let's think about this intuitively for a second here. What numbers can we square to get 9? Well, a positive number times a positive number is a positive number. So positive 3 times positive 3 is 9. So 3 is definitely a solution to this problem. But negative 3, think about it this way. Negative 3 times negative 3. It's a negative times a negative, which makes a positive. And the 3 times 3 is 9. So I get positive 9 again. So the solution to this is plus or minus 3. Another way of writing the solution, though, oops, get rid of that ruler. Another way of writing this, and this is the way I like to write it sometimes to clarify this, is it's plus or minus the square root of 9. So this is the answer to this problem by definition. Now let's talk about x equals the square root of 9. The solution to this is just x equals 3, and the reason is the square root is a function. And if you know what a function is, you might have heard this before, but for every one input, there should be one output. And you can input the number 9. You can plug in the number 9 into the square root function. You can take the square root of 9. So there should be one answer to this. And so you get to choose, is it negative 3 or positive 3? And the answer is always going to be positive 3. And that's just what mathematicians have decided to make it. You can actually make it negative 3, and math will still work out pretty easily. But it's just how the square root function works. There's problems that are similar to this when you go into complex analysis and you want to talk about the logarithm function. Weird things happen with that that are very similar to this problem. But now let's talk about doing x let's do, for example, let me think. Square root of x squared equals 4. What is the solution to this? A lot of people would obviously say 4 because 4, if you square 4 and then you take the square root, you will get 4. 4 squared is 16, square root of 16 is 4. So x equals 4 is definitely a solution to this. But it turns out that x equals negative 4 is also the solution to this. Because, the reason is because when you square a negative, then it becomes positive, and taking the square root, you can take the square root of positive numbers, you can't take the square root of negative numbers. So it turns out that negative 4 works as well, because negative 4 times negative 4 is positive 16, taking the square root of positive 16 is 4. So both solutions work. Now, if the problem were a little bit differently, get rid of that ruler. If the problem were written as, make sure I get this right, the square root of x squared equals 4. This only has one solution, and it's x equals 4. Let me explain why. You can't take the square root of negative numbers. So if you plug in the negative 4 into here and take the square root first, you have a problem because it's basically 2i. And 2i squared, well, it is 4, kind of, but you know, ruling out complex numbers for a second here, this problem only has one real solution. So it's important to understand that these two problems are genuinely different. So let me talk about that one problem that we were at. If I had something like x plus 2 squared equals 4. Now what do I do to both sides? I have to square root both sides. Now keep in mind, the square root of 4 is in fact 2, so I'm going to leave it as 2. But the square root of a square is just the absolute value. And I guess I should explain that a little bit more in detail. If I have the square root of x squared equals 4 again, this is basically saying that the absolute value of x equals 4. And what number can you take the absolute value of to get 4? That's 4 and negative 4. But you can actually check this. The square root of x squared is the exact same thing as the absolute value of x. This is actually a definition. These actually mean exactly the same thing. So if I ever take the square root of the square, I'm actually just taking the absolute value. So what this is saying is actually the absolute value of x plus 2 equals 2. And so how do I solve this? Well, the solution to this is if x plus 2 equals 2 or x plus 2 equals minus 2. Another way of saying this is that x plus 2 equals plus or minus 2. So I get a lot of people saying, oh, square root of 4 is actually plus or minus 2. That is not true at all. It's important to understand that the thing that makes this plus or minus come into play is actually over here. This square root of the square becomes an absolute value, and that's absolute value. Solving absolute value problems is a little bit different. So I get that question a lot, and it's important to understand how that question plays out, how the answer plays out. All right, so let's go to the live chat, see if we have any questions. If you guys have any questions, be sure to post your questions. Let me change screens real quick. Post your questions over here, and I will address every single question soon. So I have Be Smart is saying second. Not a question, but if you have a question, let me know. Anyone has a question, please let us know in the live chat. We are currently completely out of questions. I guess what we could do is some problems with absolute value, but I'm just going to make up some questions pretty soon here if nobody has any. But like I said, subscribe if you haven't done so already. Like this video so that more people can recognize that this video exists, and share it on your Facebook, whatever, just so that people can realize, hey, there's a free math tutoring resource every Thursday and Sunday at 9 p.m. by a university math professor. And I don't say that to brag. I say that genuinely, like they're getting real good help. So let me see if we have any math or comments. Again, post your questions, math questions over here, and I will address them. All right, looks like we don't have any math questions. That being said, I would like to talk about some of the things that we will be releasing within the next couple weeks. So we have currently about 100, I'll give you an update on Amour Learning. We have 130 professional studio quality lectures coming out within the next 2 weeks. And let me explain what this class is going to be about. This is a statistics class. So real quickly, let me show you what this class looks like. So, this is called statistics. So, just to give you kind of a brief demo of what this class is going to look like, we've already set up all the framework of this video. We're still in the post-production right now, and we're still actually producing some of these videos. But they will be released within the next 2 weeks. That is our deadline. So statistics, what is statistics? You've probably heard of this word before, but let me explain basically what it is. The idea is, let's assume you want to talk about a group of people. You want to know some information about them. Well, to know information about them, you would need to gather that information from that group of people. So let's say you wanted to figure out how many Republicans there are in the US. Well, you would need to ask every single person, are you a Republican or are you a Democrat? That would take a long time. And what you'd be measuring there is what's called a parameter. A parameter is the actual truth. This many people are Republicans. That is a parameter. But a statistic is when you gather a small group of people that maybe like 100 people, and you ask them how many of them are Republicans, and maybe you find out that like 52 of them are Republicans, or 47, whatever it might be. And that right there is a statistic. You've measured a group of people, and if that group of people really represents the United States, for example, then you can say like, hey, I'm going to make an inference. I'm going to say that 47% of the people in the US are Republicans. Now that might not be true, but it might be close. And we're going to talk about what does it mean to be close? What is a good inference? What is a statistic? What is a parameter? What are all these things? And that is what this course is going to be talking about. And we have 120 lectures, which is probably going to be close to 100, let me do some math real quick. 120 lectures, they're about 5 minutes a piece. So I'm not really good at math. 600, it's about 10 hours worth. It's probably gonna be closer to 20 hours worth of content in that class. So it's gonna be completely free. I highly recommend you check us out within the next couple of weeks, and you can see that video. So we only have 2 viewers. Looks like we don't have any more questions. So that being said, I'm going to cut this video short. Thank you guys so much. Again, just want to reiterate one more time, make sure you subscribe to this YouTube channel. Make sure you like this video. Make sure you follow us on Amour Learning on Facebook. Follow Cody Amour on Twitter. You can find me on Facebook too, and you can donate to Patreon, Kickstarter, or GoFundMe. All of those resources help us financially to support this project. But you might be wondering, what is that right up there? That is Amour Learning. That is what this organization is called, and we just provide free math videos. If you've ever seen Khan Academy, it's pretty much the same concept as Khan Academy, except it's more geared towards college level math courses, and it's very similar in production and studio quality. So we got a giant 100 square foot green screen. We have a bunch of floodlights. We have all this amazing production. We have lavalier microphones, shotgun mics, professional 4K cameras. We have all the works, and we plan on rolling out really good content within the next couple weeks. So stay tuned, and I can't wait to start pushing these things out. Thank you guys, and I'll see you guys on Sunday at 9 p.m. free math tutoring. See you then.